Welcome. Here, we break down complex electrical engineering concepts into simple, practical, and engaging explanations. So stay connected with the world of electrical engineering. Temperature effect on metal resistance. When temperature increases, the resistance of a metal also increases. This increases linear, means the resistance increases linearly with the increasing temperature. So the change of resistance is directly proportional to the change of temperature. If we heat a metal rod, the resistance increases linearly. The value of increased resistance also depends on the initial resistance that has been measured before the increment of the temperature. Suppose R1 is the resistance at temperature T1 and R2 is the resistance after heating at temperature T2. So the change in resistance, that is R2 minus R1, is directly proportional to the change in temperature, that is T2 minus T1. And also it is directly proportional to the initial resistance, which has been measured before the increment of the temperature, that is R1. So we can write the equation. R2 minus R1 is proportional to R1 multiplied by T2 minus T1. From here, we can write the equation. R2 minus R1 equals alpha 1, R1 multiplied by T2 minus T1. That alpha 1 is called the temperature coefficient of resistance at temperature T1. So alpha 1 can be written as alpha 1 equals R2 minus R1 divided by R1 multiplied by T2 minus T1. That means this is the change of resistance per 1 ohm of initial resistance per degree centigrade. This means this is the change in resistance per 1 degree centigrade of increment of temperature from T1 degree centigrade per 1 ohm of initial resistance at T1 degree centigrade, that is R1. Now this equation can be rewritten as R2 equals R1 plus alpha 1 R1 multiplied by T2 minus T1. And that would be R2 equals R1 multiplied by, within bracket, 1 plus alpha 1 multiplied by T2 minus T1, bracket close. Now we will consider the resistance value of the conductor at 0 degree centigrade as R0. Now for increasing temperature from T0 to T1, what will be the change in resistance? Let us examine, and that will be R1 minus R0 equals alpha 0. R0 multiplied by T1 minus 0. That means the change of temperature is 0 to T1, and R0 is the initial resistance at 0 degree centigrade of the resistor and alpha 0. What is alpha 0 here? Here, alpha 0 is the temperature coefficient of resistance at 0 degree centigrade, means alpha 0 equals R1 minus R0 divided by R0 multiplied by T1. That is the change of initial resistance, means resistance at 0 degree centigrade for increment of each degree centigrade from 0 degree centigrade per 1 ohm of resistance at 0 degree centigrade. Anyway, now we consider the temperature T2, another temperature. So the increment of resistance for increment temperature from 0 degree to T2 degree will be like this. R2 minus R0 equals alpha 0 R0 multiplied by T2 minus 0. This implies, now you see R1 minus R0 divided by T1 equals alpha 0 R0 from equation, say 1, and from equation, say 2. We can write R2 minus R0 divided by T2 equals alpha 0 R0. So the equation becomes R1 minus R0 divided by T1 equals R2 minus R0 divided by T2. Therefore, R2 minus R1 divided by T2 minus T1 is a constant. Now from our initial relation, we can write R2 equals R1 multiplied by, within bracket, 1 plus alpha 1 multiplied by T2 minus T1. This implies R2 minus R1 equals alpha 1 R1 multiplied by T2 minus T1. This implies R2 minus R1 divided by T2 minus T1 equals alpha 1 R1. So this constant is alpha 1 R1. Obviously, this is the slope of the straight line representing the change of resistance with temperature. As this relation is linear, that slope will be constant. So the equation becomes R2 minus R0 divided by T2 minus T0, where T0 means 0. Here 0 degrees centigrade equals R1 minus R0 divided by T1 minus T0, and that will be equal to R2 minus R1 divided by T2 minus T1. And obviously we can write it as alpha 2 R2 equals 2. So we can write alpha 0 R0 equals alpha 1 R1 equals alpha 2 R2. This is the slope of the same straight line. From here we can write alpha 1 R1 equals alpha 2 R2. From here we can write alpha 1 R1 equals alpha 2 multiplied by, within bracket, R1 multiplied by 1 plus alpha 1 multiplied by T2 minus T1 from this equation. So we can cancel out that R1 and that R1, and alpha 2 can be written as alpha 2 equals alpha 1 divided by 1 plus alpha 1 multiplied by T2 minus T1. That is the relation between alpha 2 and alpha 1, means the temperature coefficient of resistance at two different temperatures. If alpha 1 is given, we can calculate alpha 2 at different temperature. If alpha 2 is given, we can calculate alpha 1 at the corresponding temperature. If we go through one example, that will be clear. Actually, as per standard, only the temperature coefficient of resistance of any metal is given as alpha 20. That may be the temperature coefficient of resistance at 20 degrees centigrade. From here, we have to determine first the value of alpha 0, and then we have to correct the measured temperature at different temperatures. Temperature correction example. Suppose we have measured the resistance of a conductor at 32 degrees centigrade as 12 ohm, and we need to correct it for 75 degrees centigrade. For that, we first need to find out the temperature coefficient of resistance. As per standard, that will be available only at 20 degrees centigrade. From the table of the standard, we get alpha 20 equals 0.00393 per degree centigrade for copper. We have considered that the conductor is made of copper. So before going to the actual calculation, we need to first find out alpha 32, means temperature coefficient of resistance at 32 degrees centigrade, because we have practically measured the resistance at 32 degrees centigrade. From the formula, we can write alpha 32 equals alpha 20 divided by 1 plus alpha 20 multiplied by, within bracket, 32 minus 20. And that will be 0.00393 divided by 1.04716. And that is around 0.00375 per degree centigrade. Now we have to calculate R75, means the corrected resistance of the measured value at 75 degrees centigrade. So we can write the equation. R75 minus R3, 2 equals R32, multiplied by alpha 32, multiplied by, within bracket, 75 minus 32. This implies R75 equals R32 multiplied by, within bracket, 1 plus alpha 32 multiplied by 75 minus 32 means 43. Now R32 means 12 ohm. What we have measured at 32 degrees centigrade, and 1 plus alpha 32 means 0.00375 multiplied by 43. And that will be equal to 13.94 ohm. Thanks for watching. We hope this video helped you understand electrical engineering concepts better. If you enjoyed the content, don't forget to like, share, and leave your thoughts in the comments. Stay with us and stay updated with more videos on transmission lines, substations, and power systems. Until next time, stay curious, keep learning, and keep the power flowing.